Hello learners, today in the series of Applied Chemistry, we are going to discuss the topic ceramics, glass and cement. They form an important part of chemistry in daily life. Silicon and oxygen make up most of the Earth's crust. They form the basis of a class of minerals called silicates. Silicates are salts containing anions of silicon and oxygen. There are many types of silicates because the silicon to oxygen ratio can vary widely. All silicates and analogues are derived from the silicate ion. The silicon atoms can be replaced by other metals to form analogous compounds, notably aluminosilicates, in which aluminium atoms partially replace the silicon atoms. Silicate industry has several independent branches, of which the most important are manufacture of ceramics and refractories, cements, plasters, glass and pyrocerams. Today we will discuss about ceramics, glass and cement. Ceramics include all articles which are essentially silicates. In a restricted sense, those articles which are made of clay are mainly known as ceramics. Most ceramics are compounds between metallic and non-metallic elements for which the interatomic bonds are either totally ionic bond or predominantly ionic but having some covalent character. So, ceramics is that branch of technology which deals with the manufacture of ceramic articles, their technical characteristics and the raw materials used in the manufacture of ceramics. Let us discuss some types of ceramics. According to their main fields of use, ceramic materials and wares can be divided into some basic groups like structural ceramics, facing material, refractories, fine ceramics and special ceramics. Structural ceramics, articles used mainly in constructing buildings and various other structures belong to this group. For example, building bricks like common bricks, brick block, hollow tile, roof tile, drain tiles, etc. Facing material, articles used for internal and external facing of buildings and structures, for example, facing bricks and slabs and oven tiles. Refractories are the materials which retain their mechanical properties at about 1000 degrees centigrade or high temperatures. These are also used in making various parts of industrial furnaces, ovens and apparatus for operating at high temperatures. Fine ceramics, porcelain wares and glazed pottery are included in this class. They are used domestically like in dishes, wash basins, sinks, decorative articles, electrically like in electrotechnical porcelain, and in laboratories like in chemical ware and apparatus. Then there are special ceramics, a group of articles with specific properties utilized in radio industry, aviation and instruments manufacture, etc. From broader perspective and simplicity, ceramic material may also be broadly subdivided into two classes: heavy clay products and pottery products. Heavy clay products are those products which consist mainly of clay with only small amount of other raw materials. Common bricks, roofing tiles, drain tiles, hollow tiles, sewer pipes, stoneware and refractories are well-known examples of heavy clay products. Pottery products, those products which are made up of materials such as terracotta, earthenware, porcelain, bone china and vitreous china are known as pottery products. It also includes wares made of earthenware, wall tiles, electrical insulations made of porcelain or other ceramic insulating materials. Now again, pottery may be classified into 4 groups: terracotta, earthenware, stoneware and porcelain. Talking of terracotta, it includes all pottery wares made from common clays. Terracotta comprises of all porous pottery ware which are not covered with a glaze. It is not subjected to higher temperatures to allow the body of the ware to become impermeable to liquids. It can be scratched by a hard steel. Its color varies from light yellow to red, reddish brown and brown. Common bricks, tiles and hollowwares made by kumhars belong to this class. Earthenware. All potteries that are permeable or porous made from red burning clays and white clays and coated with a glaze are included in earthenware. It is harder than terracotta because it is fired at a higher temperature. Potteries which become impermeable to liquids during firing are called stonewares. Stoneware is ceramic ware with a slightly grayish or brownish body. They are dense, often glazed with a salt glaze. For example, drain water pipes, sanitary wares such as wash basins, etc. Porcelain is the pottery with a white, translucent and impermeable body. They are the best types of potteries and the composition of the body is so adjusted that when they are subjected to high temperatures, it becomes completely translucent to light. Commercially, ceramics may be classified into 2 groups: rough wares and fine wares. Rough wares are made from coarse grained ceramic draught and have a porous biscuit of non-uniform structure. For example, building materials and refractories. Fine wares are sintered or fine pour items with a uniform structure of the biscuit. Examples are porcelain, glazed pottery and special ceramics. Now let us talk about the general properties, chemical and physical properties of ceramics. The components present in ceramics such as oxides, carbides, etc. give high chemical stability to ceramics. Most of the constituent oxides are usually resistant to highly oxidizing and reducing atmosphere and also to the fluctuations in the temperatures. Compactness of the crystal structure, high directional character of chemical bonding and high field strengths of small cations of high charge are also responsible for the stability of ceramics. Now let us talk about their optical properties. Ceramics are opaque as well as transparent. However, most of the ceramics are transparent over a wide range of wavelength regions of the electromagnetic radiations. The optical properties of ceramics depend upon its composition and crystal structure because extent of polarization mainly depends upon or it is controlled by ionic size, bonding energy and crystallographic direction. It should be noted that isotropic crystals exhibit identical properties in all the directions, but anisotropic crystals which have higher refractive index exhibit properties only along the closed packed crystallographic directions. The presence of vacant electronic energy band impurities with donor and acceptor sites also contribute to the absorption in the visible region. These impurities cause color centers in normally colorless material because of the non-stoichiometry in the cation-anion ratio. The translucency or opacity in a ceramic body is due to scattering of light resulting due to difference in the refraction at the boundaries of a polyphase polycrystalline material. Now the electrical and magnetic properties. Oxide ceramics are generally bad conductors or insulators in their normal oxidation states. The non-oxide ceramics, however, act as semiconductors. Ceramics containing transition metal ions have also been found to show magnetic properties because of spins associated with unpaired electrons. Magnetic ceramics are those which contain molecules with odd number of electrons and incompletely filled d or f orbital. Unlike magnetic metals, magnetic ceramics are bad conductor of electricity and hence do not conduct electricity. Magnetic ceramics respond to magnetic field known as magnetic susceptibility. Now we will be talking about permeable and impermeable wares. Permeable or porous pottery absorbs water and shows a rough structure. Heavy clayware, refractory ware, terracotta and earthenware are the examples of permeable or porous ware. Whereas impermeable or non-porous ceramic materials absorb very little or no water. Stoneware, vitreous china, which is similar to stoneware but its color is white. China and porcelain are the examples of impermeable ceramic materials. Now classification based on the reduction in porosity of the ceramics. Classification of ceramic products on the basis of the degree of vitrification or the progressive reduction in porosity is like this: white wares, varying amounts of fluxes, heat at moderately high temperature and vitrification. Then we have heavy clay products, abundant fluxes, heat at low temperature and little vitrification. Refractories, little fluxes, heat at high temperatures and little vitrification. Enamels, very abundant fluxes, heat at moderate temperatures and complete vitrification. Glass, moderate fluxes, heat at higher temperatures and complete vitrification. Chinaware is vitrified, translucent ware with a medium glaze. Porcelain is vitrified, translucent ware with a hard glaze. Stoneware may be regarded as a crude porcelain. Sanitary ware, formerly made from clay, was usually porous. Whiteware tiles are generally classified as floor tiles and wall tiles. Now, basic raw materials for the manufacture of ceramics. The raw materials can be divided into three basic groups: plastic materials, clays, non-plastic or leading admixtures like silica, which can be quartz or sand, and crushed chamote. Fluxes or mineralizers whose addition promotes formation of liquid phase feldspar. Clay is a product of decomposition of the mineral feldspar and is more or less impure hydrated aluminum silicate. Feldspar is the most abundant mineral found in crystalline rocks, commonest of which are granite and gneiss. The third main constituent of ceramic material is sand or flint. Silica is used in the ceramic industry in the form of sand, sandstone, quartz and flint. The term flint is frequently employed for silica and refers to the pebbles which consist of pure silica and are found on chalky ground. In addition to three basic principal raw materials, namely clay, feldspar and sand, a wide variety of other mineral salts and oxides are used as fluxing agents. That means the agents which lower the temperature, and we also use special refractory materials. Now let us talk about the manufacturing process of ceramics in brief. Both glazed and unglazed products are manufactured. The glazed product is obtained by applying glaze on the unglazed body either before or after firing. That means that in all cases the unglazed product has to be manufactured first and then glazed is applied. Now the steps which are involved in the manufacture of potteries. Number one is the grinding of raw material. Raw materials other than clay are ground finely before mixing to get a uniform mixture of clay and other raw materials. Then mixing, or it is known as preparation of bodies. The raw materials are mixed in definite proportions so as to give the body the properties required and also to give the clay mixture the right consistency for the particular shaping process which is to be used. The third step is kneading. The filter cake is taken from the filter press or vacuum filters and then put into a pug mill, which is used to mix the materials in plastic or semi-plastic state. Articles other than round shape are formed in plaster molds by different methods. Then the fourth step is jolleying. Jolleying is a mechanical process of making a large number of similar articles economically. In this process, the body is formed partly by a plaster of Paris mold and partly by means of a profile tool having a partial outline of the article to be made. Then it is slip casting. It is a process of giving shapes to the claywares from the clay liquid. The slip used for this purpose is prepared from plastic body by adding a small amount of sodium carbonate, sodium silicate or caustic soda. Then pressing. It is the process used for making plastic, semi-plastic and powder bodies. Plastic bodies are used in the manufacture of tiles, drain pipes, etc. In the making of semi-plastic body, the plastic body is dried, powdered and then mixed with small amounts of water and oil. For making powdered body, very powerful presses are employed. The next step is extrusion. This method consists in forcing the plastic paste through a die or a mouthpiece of the required shape. The shape of the extrusion corresponds to the cross section of the rod, tube or bar to be extruded. After extrusion, the material is cut into pieces of suitable length. Now turning is carried out on lathes, and before turning a ceramic body, it is essential that the body should be dry to a reasonably hard state. In case of medium and large articles, the body may be in semi-hard state. Small articles such as sparking plugs are turned in hard state. Then drying. Drying is the most essential because imperfect drying may cause cracking of the article during the firing. Now firing. Substances acquire durability and many other favorable qualities not encountered in other substances when they are heated at higher temperatures. Now comes glazing. A glaze is a thin coating of glass that is melted out on the surface of more or less porous ceramic material. The glaze may be put on the ware by dipping, spraying, pouring or brushing. Types of glazes, there are three types. Number one is the raw glaze, prepared from materials which are insoluble in water. Frit glazes In these, some materials which are soluble in water are first melted with silica and then mixed with other materials insoluble in water. Salt glazes are produced by throwing salt into the fire mouth in the later stages of firing. Now, what is the purpose of glazing? To produce a decorative effect, to improve the durability of the ceramic article, to provide a smooth and glossy surface to the glazed material, and to make the surface impervious to liquids. Now comes decorations. There are two types of decorations, underglaze and overglaze. In the case of underglaze decorations, the colors and the glaze fuse directly together, while in overglaze decoration they fuse together with the help of soft flux. In this way, in this presentation, we have discussed in detail about the types of ceramics and the materials required and the process of manufacture of various ceramic articles. Thank you.